In this video, we'll learn how to solve differential equations using MATLAB. To solve differential equations, let's open a new file. Let's name this file as predator-prey model. As a .m file. And write a new function whose name matches with the name of the file. We have to fill the details of the function here between the function and the and. So I've already written the code, so I'll just take parts from it and explain what each part means. So to solve the differential equation, this code we need is this. We'll solve it using ODE 15s. You can also solve using ODE 45 or other solvers available in MATLAB. So this function takes as input the time over which you're running the ODEs, the initial conditions, and we have to write the equations for the describing the system. So that we'll write in the new function ODE model. So let's write that new function ODE model. Which takes as input two parameters, time and let's call it p. It doesn't have to be the same variable as y here because these are local variables. And there is an output to the output of this model. Let's call it out is equal to this. And within this function, we'll write the differential equation describing the system. We'll take them from here. So there are two equations, one for the predator and prey, one each for the predator and prey. So here x is for the prey and y is for the predator. Alpha, beta, gamma and delta are constants, and x and y are varying with time. So let's assign some values for all these four variables. So I'm taking the values from here. So I assign alpha as 20, beta 1, delta 2, gamma is 40, and we'll run the equations. And so this input time and p will be the initial values for the first run, and then we'll update so we will assign that value, initial value for x and y as p of 1 and p of 2. These are the initial values for the predator and prey imported for assigned to x and y. Then we'll update the values of x to the new value of x at the next interval of time using these two equations. In that updated value, let's call it dp1 and dp2. And that should go as output for this function. So we'll call the output as dp. Also the dp values here are a row vector, so we'll convert it to a column vector because that's how ODE 15s function works. It needs a column vector. Okay, so that's the ODE model part. Now we have to assign the time over which we have to run the model, tspan. Let's say we run it from 0 to 3. Let's say the units for the time span are years. Then we'll assign some initial conditions for the predator and prey. Let me take the same values I've used last time, 10 and 50. So these two values will be taken as input for ODE 15s along with the equations for the model. It should run and give us and assign values to T and P. So we'll use these 2E and P to plot the output P1 and P2 as a function of time. So let's plot it using the plot command. Okay. So I'm assigning the name of the function of this plot as PLT. So I'm plotting the variable P1 as a function of time and the variable P2 as a function of time. Here this column means for all times. P1 is for prey and P2 is for the predator. So let's run this and see if we get a plot. It says undefined function or variable ODE model. Oh, sorry. So we forgot the underscore here. So I will run it again, and we have the plot of as a function of time for both the predator and prey, the populations of predator and prey. So we don't have the axis here. Let's add the axis for x and y, and also legend showing that orange is for predator or prey and which color means what. I'll just take this part here for improving the way the figure looks. So I'll assign an x label, the time on the x-axis with some font size, y label, the time on the axis labels for the y-axis population size, some font size. And since we have called this plot as a function, I can use that. So I'm calling the line width, assigning a line width of 2. If you see, this width is not that high, so you can increase it. And the line width of 2 for a second plotting variable. Let's assign a legend, prey and predator. I'm locating it in the northeast. We can change it to southwest or wherever you want to locate the font size. Then we can assign a font size for the x and y axis. Then the background color is gray. Now we can assign it as white. Okay, let's run it again. Okay, so that's the new figure with the x and y axis labeled and an improved font size and showing the legends. So blue is for prey, which is varying from the starting concentration of 10 and oscillating, and the predator is in orange, which is oscillating from a starting value of 50. Okay, so that's how you code ODEs in MATLAB. So if you have more equations, you add more equations here, and you can plot whatever variables you want to plot using the plot command.